Hello students, so in continuation of what we have learned in class 9, in this chapter we are going to discuss some more fraction, rational and irrational numbers. We will learn a new method called method of contradiction and we will use it to prove a given number irrational. Along with all this, we will see how prime factorization can be used to verify whether a given rational number has terminating or repeating decimal expansion. Except this, we will also learn some more methods to find out HCF and LCM of positive integers. So overall this journey is going to be very much excited. So before starting our journey, let's objectify the concept map so that it will be easier for us to understand the chapter step by step with an easier approach. So the key concepts are like this. In the first part, we will recall the number system. Means whatever we have learned about the numbers throughout these 9 years, class 1 to class 9, we will discuss and recall all the facts, all the patterns, concepts on numbers we are using in our real world. Then we will move to Euclid's division lemma and Euclid's division algorithm. Wait, don't be so confused. The words may be fancy, this may not seem familiar to you, but the concepts, the old one. Okay, so this is nothing but about the division of two positive integers, and you have learned this in class 3. Okay, so while we will discuss this part, you will find this much easier, I bet on this. Okay, so next we will move to fundamental theorem of arithmetic. Again, fancy words, but the concepts, the old one. In this part we will discuss facts on prime numbers and composite numbers. Means we have known about prime and composite numbers. What is a prime number, what is a composite number, but why is it called composite number and how prime numbers are the building blocks of composite numbers, that's all we are going to discuss in this fundamental theorem of arithmetic. Next we will move prime factorization and decimal expansion. I hope I don't need to explain this point. Everyone knows how to factorize a number and what is decimal expansion, means how to convert a fraction to decimal. Okay, so in this part or in this class we will discuss how without doing the actual division. Okay, so while we are converting fraction to decimal, we are simply dividing the numerator by the denominator, but here we will determine whether the decimal expansion of the fraction or the rational number will be terminating or repeating decimal. Okay, terminating or non-terminating repeating decimal without actually dividing this. Okay, without dividing, how by using prime factorization we can determine the decimal expansion of the fraction will be terminating or non-terminating repeating. And if it is terminating, how to find out after how many places it will be terminated? We can also determine this by simple use of prime factorization. Okay, so this is going to be very much interesting. Okay, and at next part we will discuss some more facts on HCF and LCM. Means everyone knows what is HCF, highest common factor, and what is LCM, least common multiple. Okay, but also we have we know how to calculate HCF and LCM, but here we will learn some more methods to find out HCF and LCM, and also we will learn some more facts, more concepts and more patterns on HCF and LCM of two positive integers. At the last part we are going to revisit irrational number. Recall, we have visited irrational number in class 9. There we have studied what is an irrational number, what is the difference between a rational and irrational number. We have studied that the number having non-terminating, non-recurring decimal expansion is called irrational numbers, such as root over any prime numbers, means root 2, root 3, root 5, etc. and pi is also irrational. Okay, here we will how root 2 is irrational, means we will see how can root 2 be proved as irrational. Also there we have learned if any non-zero rational number is operated with any irrational number, the result is irrational. Means 2 plus 3 root 2, 5 plus root 3, all these things are irrational. And here in this class we will learn how to prove them irrational, means how to prove 3 plus 2 root 5 is irrational. And for this we are going to use the method of contradiction that I have already mentioned in the starting of this video. Okay, so after learning all these concepts, I'm sure you are going to build a logical approach to identify the patterns in the numbers, and you can also do faster calculations. So before moving ahead, let's start the first part of this video, that is recalling number system.